and welcome to this lesson. Today we want to look at the pressure in a liquid. The pressure in a liquid. In our last lesson we talked about pressure on solid. Pressure on solid, we defined the concept of pressure and talked about the pressure on solid. We said that pressure is the force that is acting per unit area, and when we hear the word pressure, what actually comes to mind is the word press. For you to press something, you must touch it. So a force does not constitute a pressure, or else the force is acting on a surface, and that is why we call it pressure. So if you have a force that is acting without touching any surface, it does not constitute any pressure. If a car is moving on the road, it is moving with a force, but as long as the car is not touching anybody, as long as the force in the car is not touching anybody, it does not constitute a pressure. So for the force to become pressure, it must be acting on a surface. So just like you must press something before you get a pressure. So when you apply a force on a surface, you get pressure. And we talked about the pressure on a solid in our last lesson. So today we want to look at the pressure in a liquid. We find out that if we put the same object, an object that has the same weight, in a container of liquid at different levels inside the liquid, the body will possess different magnitude of pressure. That is, the level or the amount of pressure will be different for the same object in the same liquid, but at different levels. For instance, at this level 1, which I call here L1, we have L1 and we have L2. L1 and L2, the same objects of the same mass or the same weight in the same liquid. At these two different levels, L1 and L2, the body will experience different pressures. Now, what we found out is that the pressure in a liquid depends on certain factors. Number one, it depends on the density of the liquid. The pressure depends on the density of the liquid. It also depends on the height or the level where the object is within the liquid. Now we also know that the pressure at the same level, they are the same. That is, if we put this object here, if we put it at this point, as we have the same level here, if we put it here, the same pressure it has here will be the same pressure it has here, will be the same pressure it has here, the same body, as long as it is within the same level in the liquid. So that is why we say that the pressure depends on height or the level where the object is located in the liquid. But if you put it at this level, the pressure it has here will not be the same thing it will have here. So the pressure will be different. Now, in overall, the pressure in a liquid depends on the density, the height, and acceleration due to gravity. Acceleration due to gravity, because the body or the substance or the object in the liquid will be accelerating. So what we have now as the final formula that shows the pressure in a liquid is P is equal to the density, it depends on the density, and height, and acceleration due to gravity, G. So it depends on these three things: density, anyhow you want to put it, density, the acceleration due to gravity, and the height of the object. So these three things must come together in your formula for pressure in a liquid. So this is the formula for it. Now let's look at some examples. An object an object is okay. So we have that an object is placed at 2 meter into a container of liquid with density of 10 kilogram per meter cube. Calculate its pressure at that level. Solution: we know that pressure in a liquid is density times acceleration due to gravity times height, now which is equal to the density is 10 times acceleration due to gravity is also 10 times height where the object is placed is 2. So we have that our P is equal to 100 times 2, 100 times 2, which is equal to 200 Newton per meter squared or Pascal. Newton per meter squared is the same as Pascal, so the two units have the same magnitude. So this is how to solve this. Now let's look at another example. Now the question, at what level at what level will an object possess a pressure of 100 Newton per meter squared in a liquid with density of 10 kilogram per meter squared per meter cube? Ten kilogram per meter cube. Solution. We know that pressure in a liquid is equal to density times acceleration due to gravity times height. Now we have the pressure 100, we know density, we know acceleration due to gravity, and then we are looking for the height. 100 is equal to 10, which is the density, times 10 times h. So h is equal to 100 over 100. So the height is equal to 1 meter. So at the level of 1 meter, the pressure of the object inside the liquid will be 100 meter per meter squared. So this is how to solve pressure that is inside a liquid.